to Fabric Monday. Today we'll talk about comparing direct link performance with the performance of other access methods. How we do that? First, it's important to review some concepts that we talked about before. If you would like, you could access these two videos about access methods to the lakehouse and about editing direct lake semantic model using tabular editor. These two videos are interesting for what we'll see today. Let's talk about semantic models cache levels. To understand the performance comparison, we need to understand the cache levels we can have on semantic models. We can have 4 levels. 1. A completely cold level. No data or schema about the object is loaded in memory. I'm simplifying some details about what is loaded in memory or not, but that's the idea. A completely cold level, the first level. Second level, a schema may be partially loaded in memory. Why a schema would be partially loaded in memory? Because the schemas are loaded in memory by demand. If a query using part of what we need was executed before, so the schema for our query may be partially loaded in memory, resulting in the level 2 of cache. The schema fully loaded in memory. Everything we need for our query was loaded in memory before. And the last level, the data cached in memory. So not only the schema is cached in memory, but the data is cached in memory as well. So we have a total of 4 levels of cache, and we need to control correctly these 4 levels of cache to understand the difference of performance between the different access methods. Access methods for comparison. We'll compare direct lake, direct query with a proxy, and direct query to SQL. We talked about these access methods before on previous videos, the ones that I made a reference on the beginning, and these are the access methods which we will compare. Let's start our work and make the performance comparison of these 3 access methods. On the server, we have here 3 semantic models. One semantic model using direct lake is the sales by delivery. One using direct query with a proxy is this one. And one using direct query to SQL, this last one. So 3 semantic models, and I have here the 3 reports. They are exactly the same report, and in this way I'll be comparing the difference between the access methods. The first thing to compare the difference between the access methods is to retrieve a DEX query, which we can use to compare the performance. We can use the performance analyzer to retrieve the DEX query. Start recording. The performance itself is not important. What's important is to retrieve the DEX query. The DEX query which is executed. Let me copy the query. Now that I copied the query saved, let's move to DEX Studio. We need to use DEX Studio to have full control of our cache. One configuration that we need to take care in relation to DEX Studio is especially the enable clear cache auto by default. If this configuration is enabled, you will have a lot of difficulty in comparison and in reaching the level 4 of cache. First, let's try the direct lake. The model in direct lake is a live connection to the Power BI semantic model. When the model is a live connection, we can't connect to Power BI locally. We need to connect to the server. How will I connect to the server? I need to go to the portal workspace settings, premium. At the bottom of the window, I have the URL to make the connection from the Dexa Studio to this workspace. In Dexa Studio, let's connect to the server. Let's make the connection. I will specify the workspace. The workspace behaves like a server, and the semantic models on this server are like databases. Let's start with the direct link. To ensure that I will first test level 1, where the test is done on everything code, I will go to the portal and then make a refresh on the direct link semantic model. A refresh on the direct link semantic model? What does this mean? This means just that I'm removing any possible information from the memory to make a very cold performance test on this semantic model. Let me put the Dex query here and let me enable the server timings. Let's execute. The query is completed and these are the timings for our query. Let's take a note of these timings. 1297 milliseconds in total. The storage engine CPU took 343 milliseconds, while the storage engine itself took 251 milliseconds. The formula engine took 1046 milliseconds. Now we have the result for the code cache for direct link. Let's try the cache level 3 with our schema already loaded in memory. The level 2 is very difficult to achieve. This means to have the schema partially loaded in memory, and then there will be many variations of the level 2. We already executed our query, so our schema is already loaded in memory, so we'll go to the level 3 of cache. In order to make the test of the level 3, we just need to click one button, the clear cache button, because after executing the query the first time, the data is in cache. If I execute again, I would be testing the level 4. No, I want to test the level 3. So let's click on the clear cache button. And now we can execute the query again. And here are the timings for our level 3 cache. Mind that there is no data cache. The storage engine was used to retrieve the data from the disk. Let's take a note of these timings. The total execution time was 125 milliseconds. The storage engine CPU time was 313 milliseconds. The storage engine time was 110 milliseconds, while the formula engine was 15 milliseconds. In this way, we are seeing the direct link level 3 cache, with the schema already loaded in memory but no data cached in memory. Now it's time to test the level 4 with the data cached in memory. In order to test the level 4, the only thing we need to do is to execute the query again, because we already tested level 3. The data is in memory. Executing again will be testing the level 4. So I will execute the query again. Mind the timings now. Storage engine is with timing 0 and the storage engine cache is 100%, so the data was completely in cache. Let's take a note of these numbers. And this is the timing of the direct link 4. Of course, it's a great timing, but we can't have our data every time in the memory. So if we achieve the level 3 of cache, this is great. It's not a good timing if we achieve the completely cold cache. This may be a problem. When comparing the performance of direct query with a proxy, the process may be a bit more complex. Why? We have at least two different scenarios. One scenario is where our direct query semantic model is linked to the lakehouse, the full semantic model. And the second scenario is where our direct query semantic model is linked to a custom direct lake semantic model, not the default one, but a custom one created by us. Why these scenarios are different? Because we have no control of the refresh and cache of the default semantic model, but we can do that with a custom direct lake semantic model created by us. Let's test these two situations and check the result. I'm on the Power BI portal. On the first scenario, I will test a direct query semantic model linked to the default semantic model of the lakehouse. The default semantic model of the lakehouse is on another workspace linked to the lakehouse, and we have no control of its refresh. Let's make our additional performance test. Here in DAX Studio, I will ensure I'm connected to our correct semantic model, the direct query proxy, which is linked to the default semantic model of the lakehouse. And I will enable the server timings. Record. Let's make a refresh of this semantic model. Done. Back to DAX Studio. Let's execute our query. These are the initial timings resulted from our query. Let's take a note of these initial timings. Considering these timings, the environment was completely cold. Now let's make a refresh on our semantic model, direct query proxy, but we have no control of any refresh of the default semantic model. Let's get back to the DAX Studio, clear any possible cache, and execute. Here are the new timings. Let's take a note of this timing. We can note, although we did a refresh on our semantic model, it's clear by this refreshing time that some cache is still in memory. It's on the default semantic model of the lakehouse. Let's try again, this time without making the refresh on our semantic model. I will stop the server time execution, record again, clear any possible cache, and run, but without making dataset refresh. We have even better timings. Let's take a note of this time. So even better timings because the second dataset didn't refresh. We haven't refreshed the second dataset. Let's stop server timings, record again. And this time I will not clear cache. I will just run the query. The times are even a bit worse. What's important to note in relation to this timing is that there is no storage engine cache. This is a behavior of the direct query mode. Direct query mode doesn't create a storage engine cache. Let's take a note of these last timings. We note that the phone engine reduced the time, but the storage spent more time to retrieve the data. As I mentioned, we have no control over the default semantic model of the lakehouse. It may have removed something from the cache, we have no control of it. Let's take a look on our portal again. Now I have a different scenario. I have one semantic model linked to a custom direct lake semantic model. In this case, I have control of the refresh of both semantic models. Let's make a refresh of both semantic models. And the consumer. Back to DAX Studio. Let's connect to our consumer semantic model. DT to DL, direct query to direct click, ensure we have nothing in cache, and execute. So this is our first timing. Let's take a note of this timing. Back to Power BI portal, let's leave the source dataset as it is, but refresh the second one, the consumer. So I have the consumer completely cold, but the source is not cold anymore because it was already consumed before. Back to Dex Studio, I will clear the cache, the server timings are enabled, and I will execute. The timings are slightly better. Let's take a note of these timings. Back to Dex Studio, without making any semantic model refresh, I will just clear the cache and execute again. We have another improvement on the timing. Let's take a note on this time, because this time both semantic models are hot. Now let's talk about direct query to SQL, which is another option to access our lakehouse. We can use our semantic model, direct query semantic model, accessing directly the SQL instead of passing through another semantic model. One difference we will notice is that in this scenario there is no cache of the schema, so the timing is mostly constant. It varies a bit, but nothing that we can notice as a specific caching being made. On Dex Studio, let's connect to our semantic model using direct query to SQL. Here it is. On Power BI, I will refresh this semantic model. Back to Dex Studio, let's stop the server timings, start again. Let's clear any possible cache we may have and execute the query for the first time. So these are our first numbers on direct query to SQL. It's interesting to note we have a warning of an error in relation to the SQL, but we have no control of the SQL. The SQL is generated by Fabric. Fabric is still very young product, and I have been noticing this warning happening sometimes. When this warning happens, the timing is usually very high, but after this first moment when this warning happens, the timing will get way lower. Let's see this happening. First, let's take a note of this time. Back to Power BI, I will refresh again this semantic model. Back to Dex Studio, I will clear the cache and execute the query again. The warning disappeared and I have way better timings. Mind how this is strange, it's different. Because I refreshed the semantic model, it should be a cold call, but still I don't have the warning anymore. It appears only once and I got way better timings. Let's adjust our table to hold a new column of information. Now we have a column called cold after refresh. Let's take a note of the numbers on this column. Back to the Dex Studio. Let's clear the cache and execute again this query without making any refresh on the semantic model. You may notice the time is very similar, only slightly different. Let's take a note of this time. You notice a reduced a reduced amount of processing on the formula engine, but it was more or less like this on the first execution as well. So the timing for the direct query with SQL is mostly constant. It varies a bit according to the connection to SQL and the reply of the SQL database. It has some variations, but is mostly constant. It doesn't have many cache levels in the middle like the other ones. Now let's analyze the numbers one by one here on the screen. There is no question, the direct lake one is the best one, is the fastest one, but it's full of limitations. We can't make a composite model. Then we have the other two options, direct query to the full semantic model and direct query to a custom semantic model, and both are quite similar, but to a custom semantic model, it's slightly the same, but giving us more control of the result. And finally, we have the direct query to SQL. The direct query to SQL seems to be the worst one, but the direct query to SQL allows us to use the import mode. And using the import mode, we can use aggregations, what we can't do with direct query in the other modes. So, in some special situations, the direct query to SQL may make a faster result than some others, not because the retrieval of the data, because the aggregation features in Power BI will allow to handle way less data than the others. Thank you very much for watching. See you next week.